In this video, we are going to discuss about volume as volume as triple integral. Just like in the previous video, we discussed like between certain limits in a 2D region. If you are going to consider limits in 2D region, if you are going to integrate between that limits, we are going to get the area. As it is in 2D space, we have only area itself. If you are going to consider 3D space, if you are going to integrate like small cubes in it, or small cubites in it, uh, if you are going to integrate, I mean, going to sum up all the cuboids in a particular region, then we are going to get fluid volume. Just consider if I'm going to pile up lot of cuboids like this here, if I'm going to pile up like this up to this height and up to this depth and up to this width, if I'm going to pile up all the things, I'm going to get an what we call pyramid, triangular pyramid, and I'm going to get an area of that triangular volume of that particular triangular pyramid, right? I have just assumed that, and the another axis is up to your face. Just consider just small regions like this, and I'm going to add up small regions, small regions, small regions, small regions, small regions, small regions, small regions. And I'm going to pile up all the things. I'm going to pile up all the things between the limits. We have limits, right? From here to here, and from here to here, or here, plus or minus something. And we have like from your screen to your face. This is z-axis. If you are going to pile up all the things between all the region between these limits, we are going to get the volume of this region, right? That's what used as a principle for finding the volume of a particular shape by using triple integral. If you are going to, if you look at a problem, then we are going to get a clear cut idea about this thing. Just look at this problem. Yeah, calculate the volume first by a solid body whose boundaries are x equal to 0, y is equal to 0, and this is a plane of 3D, and z equal to 0. Uh, this plane is has intercept of A in each direction. Just it might be the A, it might be the A, and it might be the A length. I'm just considering. Sorry. Uh, and I formed a triangle by I'm forming a plane which is connecting three axes. Just try to visualize an plane which is trying to cut an three axes at a length of A in each of the axes, and we have to find the region bounded from below this plane and x equal to 0 plane, y is equal to 0 plane, and z equal to 0 plane, right? We are going to get the whole space in that region, right? Just try to look at it. A simple evaluation: triple integral of dx, dy, dz. Yeah, obviously we have lower limits, uh, x equal to 0, y is equal to 0, z equal to 0. If z equal to 0, then I'm going to get a limit of z of a function which doesn't contain z, right? And this is the whole function we have. And I'm going to write the another limit of z as z equal to a minus x minus y. Now I will get rid of this dimension. Now I'm left over with two dimensions itself. Just consider in that way. This might not be the original thing which we are doing. Now I'm in a space of 2D. Now we are taking the limits of y. So I'm going to get a function with which contains only x variable without any y. So the limit will be y is equal to a minus x, right? And here I'm going to have only one dimension. Now I'm going to neglect y value also. Now I'm left over with x equal to a limit. That means integral of 0 to a. Yeah. Now let's carry out our integration. Integral 0 to a, integral y is equal to 0 to a minus x. Now I will integrate dz. I'm directly substituting the limits. A minus x minus y minus 0. I'm not considering it. dy dx. Now we are going to integrate with respect to y. Ay minus xy minus y square by 2 between the limits y is equal to 0 to y is equal to a minus x. Now just keep the y values. A into a minus x minus of x into a minus x minus of a minus x whole square by 2 minus 0. I'm not going to consider those things, and I'm going to keep limits as 0 to a. Now I'm going to simplify this function. Yeah, a square minus ax minus xa minus plus x square minus a square by 2 minus x square by 2 plus ax. Right? Now I'm going to counter off these two things. Now I'm left over with these things. Okay, right? I'm going to integrate these values. A square by 2 plus x square by 2 between the limits 0 to a. I will get a square x by 2 plus x cube by 6 between the limits 0 to a, right? A cube by 2 plus a cube by 6. Then I'm going to get the value of this particular integral as 4 a cube by 6. That means 2 by 3 a cube. This is the volume of the region formed by using given boundary condition. Yeah, we founded a area volume of a particular space which are found by using the given boundary condition, and it turned out to be like 2 by 3 a cube. This is all for this video, guys. Thank you. Meet you in the next video. Bye.